Okay, in this lesson we're going to be looking at solving proportions. Might need to review real quick what a proportion is. Remember that ratios that are equivalent are said to be proportional. And equivalent ratios are ratios that make the same comparison with different quantities. Let's look at this example again. We've already seen it before, but if we were to find the ratio of shaded to unshaded boxes or blue to white, let's see, we would count the blue and we have 7 blue or 7 shaded to 5 that are not shaded. That's a ratio 7 to 5. And over in this diagram, we had 1, 2, 3, 4, 5, 6, 7, 8. So that's 8, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 20. 28 that were shaded and 20 that were not. So here are two ratios, 7 to 5 and 28 to 20. I'm going to write them both as fractions. And you will notice that they actually say the same thing. 28 to 20 can be reduced to 7/5. If we divide 28 by 4, we would get 7. And if we divided 20 by 4, we would get 5. So they both are a ratio of 7 to 5. And we write them as fractions with an equals with equal sign in front of them. That is a proportion. We're going to use our understanding of a proportion to actually solve problems that have a missing amount. Let's go ahead and look real quick at this proportional reasoning problem just to make sure we understand what we're doing here. This says that Mr. Smith has a class with 6 girls and 10 boys. Mrs. Thompson's class has 15 boys and 9 girls. Then the question says, do Mr. Smith and Mrs. Thompson have proportional classrooms? Well, what we do is we set up the ratio, and I'm going to use a ratio of girls to boys, so girls to boys. And the ratio in Mr. Smith's class is 6 to 10, and I'm going to write that as a fraction, 6 to 10. In Mrs. Thompson's class, the ratio of girls to boys is 9 girls and 15 boys. And I'm going to write that as a fraction as well, 9 to 15. Now, if we reduce these fractions, or these ratios, to their simplified form, here's what we end up with. What's common between 6 and 10, the greatest common factor would be a 2. 2 goes into 6 3 times. 2 goes into 10 5 times. So in Mr. Smith's class, the actual ratio of girls to boys is 3 to 5. And in Miss Thompson's class, again, I'm going to simplify this fraction. 9 divided by 3 is 3, and 15 divided by 3 is 5. And you will see that in both classes, they have the exact same ratio of girls to boys. These are equivalent ratios, and they are said to be in proportion or proportional. So yes, these classrooms are proportional. So now let's take this understanding of a proportion and use it to solve some problems. Here we have a department store, JA Department Store, that is selling 3 pairs of children's socks for $5. Mrs. Wagner wants to buy a dozen pairs of socks. How much will it cost? Well, in the first statement there, we have a ratio. They are selling 3 pairs of children's socks for $5. So 3 pairs for $5. In the second ratio, or in the second statement, Mrs. Wagner wants to buy a dozen. A dozen is going to be 12. And that is going to cost, well, we don't really know. So we're going to put a question mark there because we're not sure what that is. But what we're going to do is we're going to set up a proportion. Make sure we understand this is a dollar sign here. So 3 to 5. So let's go ahead and write this as a fraction of 3 to 5. and we're going to set it equal to, because the cost of the 12, or the amount of 12 socks for what it costs, is the same ratio of $3 to $5, but we're changing that 3 from a 12 to a, and then we don't know this amount here. We would actually want to algebraically give that a variable, and we could call it an x. Now, there are different ways to solve proportions. One way is to just look at your fraction. If we are going from a 3 to a 12, we need to multiply times 4. So if we've multiplied the quantity, or the amount of the pairs of socks, by 4, we're going to multiply the price times 4, and 5 times 4 is 20. So we're going to end up paying $20. Now, if we solve it as a proportion, we can also cross multiply and divide. We can multiply 3 times our unknown, or 3x, set that equal to 5 times 12, which is 60. Now we have an equation that we need to solve, and this says 3 times what is equal to 20. Well, if we will divide both sides by 3, 3 divided by 3 is x, and 60 divided by 3 is 20. So again, our unknown is going to be 20, so it's going to cost Mrs. Wagner $20 to buy a dozen at the ratio of 3 pairs for $5. The fraction of 12 over 20 reduces to 3/5. 12 divided by 4 is 3. 20 divided by 4 is 5. So that is setting up a proportion and solving. Let's go ahead and look at one more example. This says that the ratio of volleyball players to football players on the high school campus is 2 to 7. So regardless of how many players there are, the ratio of volleyball to football players is 2 to 7. Now, if there are 24 volleyball players, how many football players will there be? Well, we already have our ratio of 2 to 7. Now, let's make sure we understand that the 2 is the volleyball players and the 7 are the football players. So that when we set up our proportion, we set it up identically. It tells us that there are 24 volleyball players, so our numerator, or the top number, is going to be our volleyball players of 24. And then our football players is going to be our unknown, or our X, or maybe our question mark. Again, you can look and see we multiplied 2 times 12 to get 24, so we could just multiply 7 times 12. But let's go ahead and cross multiply and divide. Again, we're multiplying 7 times 24. 24 times 7. That is going to give us 168. And then we're going to divide by the 2, because it's 2 times x, so we'll divide by the 2. And 2 goes into 168. Let's see, 2 goes into 16 8 times, which is 16. We have nothing left over. Bring down our 8. 2 goes into 8 4 times. 4 times 2 is 8. So we have a total of 84 football players. And again, the ratio was 2 to 7. So 24 out of 84, or the ratio of 24 to 84, should reduce to 2/7. And it does, because 24 divided by 12 is 2, and 84 divided by 12 is 7. So that is the concept of setting up a proportion to solve a problem.